So in today's video, I have brought you a very nice problem that was suggested by viewer. Here is the following statement. For all x, y, and z as non-negative real numbers, satisfy this following condition. We have the sum of these values of x and y and z equals 3. So this one is taking us to prove the sum of these squares, x1, xy, x square plus y square plus z square is superior to 3. Okay? So in fact, the only issue with this problem, we don't know how smaller or bigger these values of x, y, and z. Okay? So regardless of these values, we are going to prove this one in such ways. You guys, you can give the kind of exploration for this value since you have the sum of these terms equals 3. So we are going to play around with that. You are going to figure out which one is smaller, which one is bigger. Okay? So anyway, we are not going through that. We are going straight to the solution. So now, first of all, we are going to assume we have equality for these values. X equals y equals z. Okay? So let's break this one into two cases. Case number one, if x equals y equals z equals 1. This equality will be occurred if only if we have these three values are equal to each other. Okay? So this one is driving us to say 1 square plus 1 square plus 1 square, which equals 3. So now we are good to go because we have proven, since we have this superior to 3, have equality sign here, which means we are proven the first case. Let's move on to the second case, which is a little complicated. Okay? So without loss of generality, let's assume x is strictly inferior than y and y is strictly inferior than z. Okay? You guys, you can take the different directions. So I'm taking it this way, making x smaller than y, y smaller than z. Okay? So before we get started with this one, we are going to prove x cannot be bigger than number 1. Okay? Let's do it by the way of contradiction. It's not even by the way of contradiction. Let's suppose x strictly superior than number 1. We will find it's impossible to be like that. Okay? So if x is strictly superior than number 1, since we have this inequality here, we know z is strictly superior than y, y is strictly superior than x, and x is strictly superior than number 1, based on this assumption that we have chosen here. Okay? Now let's sum these values. So we get this one is telling us x plus y plus z, which is strictly superior than 3x. Since we get x strictly superior than number 1, this one is telling us this one is strictly superior than 3. Okay? But we get the sum of these values equals 3. It's strictly impossible. What does this mean, impossible? Which means this one is absolutely x must be inferior to number 1. Okay? So this one is driving us to tell us x equals 1 or x is strictly inferior than number 1. Okay? So for x equals 1, we already proven that. We have a solution for that. Now we are on this one now. So now our assumption is true, which means we have which means x must be strictly inferior to number 1. Okay? Let's build our proof based on this condition that we have here. Okay? So let's start with this one. We know x plus y plus z is raised to the number 2 as a power. So I'm going to expand this one out. This one is giving us x squared plus y squared plus z squared plus 2 times xy plus xz plus yz. Okay? If you distribute this one, is going to give us this one. Remember, this one, it was equals 3, which means this one, it will be replaced with 9. Okay? Now I'm going to leave this one like this. Let's stick this bunch of these terms to the left. I will be left with this one. I get x squared plus y squared plus z squared, which equals 9 minus 2 times xy plus xz plus yz, like this. Okay? Since we've been asked to prove this one, so we are going to prove this one. This one must be superior to 3. Okay? Let's work on this one. At the end, we will find this true. Okay? Now let's take this number 3 to the left. Now let's take this 3 to the left of this inequality. Becomes 9 minus 3, which is 6, minus 2 factor xy plus xz plus yz, okay, which is superior equal to 0, okay. Then move over this one to the right and divide both sides by number 2. I will be end with this one. 3 must be superior equal to xy plus xz plus yz, like this, okay. So I have ended with this nice expression. I'm going to remind you about very important and useful formula. It's called AMG theorem, arithmetic mean value geometry theorem. So AMG theorem for A1 all the way down to the AN, all are positive, which means E sub 1 plus E sub 2 and all the way down to the E sub n must be superior equal to divide by n superior equal to E sub 1 factor E sub 2 and all the way down to the E sub n. All is raised to the 1 over n as an exponent, okay. So I'm going to apply this theorem on this one here. Since we have 3 consecutive sums here, since we have 3 consecutive terms here are positive, now we are allowed to apply AMG theorem. So we get 3 is superior equal to xy plus xz plus yz, which they are superior or equal. We have 3 terms, so we get 3 here. Factor xy is multiplied by xz is multiplied by yz, all is raised to the 1 over 3 because we have 3 terms here only, okay. Since you have this inequality here, z strictly superior than y is strictly superior than x, we are going to cancel this one out because this one we are using it when we have the contradiction. So now we've done this one, we know x is strictly superior than number 1, we are dealing with this one now, okay. X must be strictly inferior than number 1. So we know xy is strictly superior than x squared because y is bigger than x. Also this one must be strictly superior than x squared, also as well as this one. So we get this one is strictly superior than x squared as well, okay. Now let's cancel number 3 from both sides here. So let's replace this one with number 1, okay. Now I will have number 1, which is strictly superior than x squared is multiplied by x squared is multiplied by x squared, all is raised to the number 1 over 3, okay. Let's put this one together. This one is going to give us x to the 2 plus 2 plus 2 as an exponent, all is raised to 1 over 3, which equals x to the 6 all to the 1 over 3, which is going to give us x squared, okay. We get number 1, which is strictly superior than x squared. This one equivalent x squared is strictly superior than number 1. I flip this inequality. So x must be strictly inferior than number 1. If x squared is strictly inferior than number 1, this one is telling us x must be strictly inferior than number 1, which is satisfied our condition, okay, which means it's true. So we have proven this one successfully. So I have ended with this video. By the way, don't forget to hit the subscribe button and support our channel, and thank you for watching. I will see you next video. Bye.